The velocity of a particle traveling upwards is given by v of t equals e to the 2t feet per second. If the height of the particle is 3 feet at t equals 1 second, what time is the height 6 feet? So this little part of our sentence right here is simply telling us that if you plug 1 second into the height function, it will equal 3. So they're simply giving you a point on the height graph. And then the question is actually, what time is the height equal to 6? So what we're going to try to figure out here is, what do we need to plug in to get a height of 6 feet? So the first thing we're going to have to do is have to find the height function itself, because we're given velocity, so we can't answer any of these questions without the height function. So we find the height function, h of t, by integrating the velocity function. And that means that's the integral of e to the 2t dt. So the antiderivative of this is going to be 1/2 e to the 2t plus c. Now, some of you, this is technically could be done with u substitution, where u is 2t. But for problems where all we have is like a constant, many people can do this in their head. So there's no real reason to go through all the u sub steps unless you need to. If you're the kind of person that you just need to go through all of that to make sure you got it correct, you can always verify your answer by simply taking the derivative, and it should give you back what you started with in the integral. So the derivative of this would be 1/2 e to the 2t times 2. The 2's would cancel and you would end up right back here. So you can check your answer doing that. All right, now this is an incomplete height function because we have a plus c here, but we were given a value on our graph which will enable us to actually solve for this c. So h of 1 means if we plug 1 in, we have e to the 2 times 1, which is e squared, plus c. This should equal 3. So we now can use this to solve for our value c. So this implies that c is equal to 3 minus 1/2 e to the 2t. So when you solve for c, you're actually not done until you write a complete h of t equation. So don't forget to go back and fill in that missing piece. So e to the 2t plus 3 minus 1/2. Oh, sorry, this shouldn't have a t here, my bad. It should just be e squared, 1/2 e squared. So it's not pretty, but it works. So that's what we have. All right, now the actual question we were asked is, well, for what value t is the height equal to 6? So now we're going to take our height function that we just completed and set it equal to 6. So now we want to solve for t. Sorry, I didn't mean to, marker slipped. Solve this for t. So that means get t by itself. So I'm going to leave the 1/2 e to the 2t. Move everything that's doesn't have a t with it to the other side. So 6 minus 3 is 3. When we move this over, we get plus 1/2 e squared. A nice handy little trick that I like to use so you can eliminate all fractions out of the problem very quickly is you can multiply both sides by the common denominator. So the common denominator here would just be 2, because we have a 2, and a 1. So I'm going to multiply both sides by 2. So when I distribute the 2 across, I simply have e to the 2t equals 6 plus e squared. Now that this e to the 2t is by itself with no coefficients, this t is trapped in the exponent. So if I multiply, or excuse me, plug each side into the inverse, which is ln of x, that will allow me to wipe this out and just deal with the 2t. So I'm going to take the natural log of both sides. The left side just becomes 2t. The right side does not simplify in any way, so you just have to let that ride. And then t is going to equal 1/2 natural log of 6 plus e squared. This will be in seconds if we're being thorough. And so this is our final answer.